Welcome to Application Packaging and Deployment. I'm Bob Kelly. I'll be discussing application packaging and deployment, as well as some processes and tasks that surround this topic in order to provide a complete picture of the application deployment lifecycle. Allow me to quickly introduce myself. I've had a long career in IT and have specialized in application packaging and deployment for much of it. My first big project was a 10,000 node migration of a government network from Next to Windows NT back in 1999, where I led the implementation and use of Systems Management Server. I went on to provide similar services for several other government customers over the next few years. During this time, I began sharing my research and application deployment topics via appdeploy.com. The AppDeploy project gained a good following and was eventually acquired by Case in 2007, which was later acquired by Dell. In addition to community management, my primary role became that of a product manager, and I later gained experience and certifications in Agile. The attention garnered from AppDeploy allowed me opportunities to write books and articles for companies like InstallShield, Wise, and Microsoft. I have a portfolio of my work on bkelly.com, where you can find links and copies of these materials. While at Dell, I managed the development and operations of IT Ninja, which was a rewrite of my original AppDeploy community. I always like to start a discussion like this by establishing some terms to ensure that when I say package, you know what I mean. I do this because I've found a lot of people define such things differently. Packaging, or to be a packager, is sometimes confused with repackaging. What I mean by packaging is to perform the research and tasks necessary to produce a custom, silent installation of software. Such work may or may not involve repackaging. By repackaging, I mean to reverse engineer a setup by capturing all of the changes made by a software installer in order to realize your own silent installation for deployment purposes. Repackaging is less common today thanks to Windows Installer and increasing awareness by software vendors that automation and customization are important to enterprise software customers. Finally, to script means to automate a series of tasks. This could be with a PowerShell script, or it might be a simple batch file with a silent command line inside. A script is commonly an artifact of a package. Though I believe widely accepted, these are my own terms, and I share them here just to clarify what you're hearing from me. If you look around, you'll find there are many lifecycle processes out there. For applications, they're often from a development perspective. What I've built here is focused on application management from the perspective of an IT administrator. Now, we're going to go through each of these throughout the presentation, but this is the framework on which I'll be focusing. We'll start with discovery and inventory. Do users in your environment have the ability to install new software? Quite often the answer is yes, and this means the applications you may need to manage is a constantly moving target. You might like to think that you can focus only on select business applications, but the reality is that you need to know what's out there so that you can remove it if it doesn't belong or patch it if a security vulnerability is exposed. Discovery is often associated with migration project, associated with new version of Windows that's being deployed or new hardware that's being rolled out, and so you have a new corporate image that needs to be updated. Another key trigger for discovery efforts is around mergers and acquisitions. There can be a lot of hidden costs in software licensing as well as risk, which makes a full software audit a common task in these scenarios. But really, when wouldn't you want to know? Malicious or vulnerable software must be attended to on an ongoing basis. I thought it worth pointing out the value of a software catalog here. When you look at add and remove programs, you get the installation details provided by the vendor's installer. The files themselves also have version information that can shed more light on exactly what you have installed. However, vendors are often inconsistent in how they refer to their software, their versions, and even their company names themselves. For reporting purposes, this can mean having to reconcile Microsoft versus Microsoft Corp versus Microsoft Corporation. For versions, we see references only to major versions, to KB article identifiers, to overlapping use of years or Roman numerals to identify a version. All this can be a nightmare to rely upon when you seek some clean reports. But it can be even more a challenge when you need to know what build of a given application you have installed in order to determine your exposure to a known vulnerability. What edition of an application is installed may also be dependent upon license or the presence of additional files on the system. A software catalog is more of a feature, not a product. It's not an inventory solution in and of itself, but it is a big differentiator that I wanted to highlight here because there's no shortage of inventory solutions out there, but raw inventory data can be of limited value depending on your needs. When you look to add or remove programs in Windows, you can see what it is you have installed and can modify or remove the applications as supported. The information driving that interface is all found in the uninstall hive of the registry here. This is the source of raw inventory data. Some applications will provide the information you need, others will not, but it's the inconsistency between even versions of the same product where the challenge comes in. This is also the place in the registry where you can find the uninstall string for each application, which is helpful when you're working to automate the removal of software. These uninstall command lines are often not silent ones, as you likely need, but it provides a helpful starting point in the research process. Solutions like SCCM include a software metering capability. There are many software metering solutions on the market, often connected to a software asset management solution. Should you pay for maintenance of an application that's not being used? Pay for only licenses you use. Should you monitor for security vulnerabilities and patch applications not being used? Remove those that you don't need. App Locker can be configured to provide rule-based usage data in the event viewer, but it's likely inadequate for most metering scenarios. App Locker is intended to limit application execution to protect against unwanted software, enforce licensing compliance, and to enforce software standardization. It can also run in an audit-only mode where all access activity is registered in event logs. With a good event log dashboard system, you could lean on this as a source of software inventory metering data, but it isn't what it's intended for. There are two kinds of metering: active metering and passive metering. With active metering, you can halt the execution of an application when too many concurrent licenses are in use. If you have 10 licenses and an 11th person goes to run it, they'll be prevented from doing so. Whereas with passive metering, usage is recorded to allow for valuable reporting, and then you can buy more licenses or renew less licenses as usage dictates reactively. The more software you have to manage, the more it costs you through the need to provide some level of support. More software equals more risk. If you have software with overlapping functionality, particularly if you're paying for those applications, there's a lot of benefit in standardization. I realize I'm expanding on the definition of discovery a bit here, but there's finding applications in an environment so that you know what you need to package, patch, and deploy. But as I said, that's typically associated with a migration scenario. This same phase can also encompass any other process you may have for introducing applications and updates to your environment. I say this not so much to extend the definition of discovery, but to better show that the same application lifecycle applies regardless of how applications may be introduced. Next, let's talk about the research aspect of the application deployment lifecycle. I strongly recommend against the urge to jump right into packaging. If something should go wrong, you'll immediately blame your package when it could well be a compatibility issue. Install the software interactively as you would if you were doing so on a single machine. Make note of installation options, see that it works, and investigate its default settings. Documenting or screenshotting the installation process is a common practice. Why? Once automated, it can be easy to lose track of what was done. Once installed, make sure it runs as a user with non-admin privileges. It could be that the application will not function as intended under normal user credentials, which can be easily missed if testing is performed with the same account that runs through the installation. The application owner is sometimes made responsible to track announcements regarding the application. Is there a new version, a vulnerability that needs patching? It's difficult for a couple of people to take on this responsibility for an entire organization, so having an application owner assigned can help distribute that workload and responsibility. Of course, an automated system to back up this manual process is invaluable, but not everyone has all the tools they need. Sit with the application owner and run through the installation and configuration of the application. Having notes regarding this, as well as one or two common tasks related with the application, can be valuable for quality testing in the absence of the product owner. In fact, as you go through this process with the application owner, it's wise to document as thoroughly as possible, as though the product owner will not be with you again, for they may well not be for any number of reasons. It may save users significant time to have corporate defaults for the application included as part of the deployment. This means identifying and understanding those settings within the application and ultimately determining where and how they are stored so that you can include such in your package. Next, we'll focus on the package phase of the application deployment lifecycle. Creating a deployment package for a Windows installer setup and for a non-Windows installer setup, which I'm calling legacy here, are two very different processes. Step one is to determine which of the two you are working with, and simply looking for a .msi file extension isn't good enough. Whether because people just expected a setup to be called setup.exe, or because setup.exe serves as a bootstrap to install installation dependencies, most setups come as executables, even when they are Windows installer packages. You can use a zip tool to extract the setup contents if it's a self-extracting executable, or you can run it and go to the temp directory to copy the contents out into a working folder. Some other ways to confirm if your setup is a Windows installer setup is to watch Task Manager, check the application event log, or watch for the generation of log files. Once you've eliminated the setup as being a Windows installer based setup, you have two choices. You can determine what command line support is provided by the vendor to silently install it and hopefully customize the installation, or two, you can repackage the setup and create your own silent custom installer. Before Windows Installer became so prevalent, and before vendors started making special effort to produce automated silent custom installations for us, repackaging was very popular. Today, it's less common. Vendor support is among the biggest benefits of a legacy setup. When you repackage a setup, you lose any installation logic that may have triggered certain changes based upon the system on which it was being installed. Plus, if you have problems with the software, you'll need to reproduce it on a machine where it was installed normally if you expect any kind of support from the vendor. Assuming you figure out how to silently install it from the command line quickly, it's by far the fastest path to deployment. With the exception of group policy, virtually every deployment system ever built is capable of running a command line installation, so it's widely supported. Most applications today are patched via delivery of a full installer versus a lightweight installer that just replaces files that are necessary. However, even the replacement of an installation by installing a newer version can be done with less risk if the original installation was performed with the vendor setup. But it's not all good news here. Legacy setups frequently provide little to no customization options, leaving you to figure out how to include customization externally following the vendor setup. Command line support isn't easy to uncover either. How an application can be automatically installed may change with any given release. While repackaging a setup exposes all the changes it makes, running a command line installation can be less transparent. Some wary of changes made by a setup will choose to capture a manual installation as though it was being repackaged, solely for the purposes of confirming the changes being made to the system. While less popular today, there are some benefits to repackaging, some of which I've already stated, but quickly, consistency. Even consistency in process. Doing the same thing for every application provides a more easily repeatable process. When it comes to customization, you can make any changes you wish as part of the snapshot process, which can then alleviate the most challenging aspect of creating a custom deployment package. Finally, awareness. As I stated, you'll have a full understanding of the setup contents and changes being made to your system. And as if you needed any, there are still some further drawbacks to repackaging. It can be complex, and it may require good working knowledge of Windows Installer and its many capabilities. If you include too many files or exclude too many files, you can end up with errors, a broken installation, or an installation that cannot be properly uninstalled. Finally, not all applications can be repackaged. Windows Installer can't make changes to Windows protected files, which is why things like IE and Media Player aren't provided as Windows Installer packages even by Microsoft. If you are repackaging, here's a quick list of items to avoid. Most of this may seem pretty obvious, but the packaging process is the bundling of changes made by a setup, and many good administrators have accidentally included things that do not belong. When faced with a frustrating MSI that's difficult to customize, you may be compelled to just repackage it, but doing so is against best practices for a reason. You are very likely to run into problems, and updates will fail because all GUIDs from the original setup will have changed. When repackaging, it's important to start with a clean machine. By clean machine, I mean Windows and the latest deployed updates should be all that exist. The logic behind that is with so little installed, the installer will not skip anything that it otherwise would because of something present on the system. Further, a clean system will be less noisy, and the likelihood that you may accidentally include superfluous changes can be minimized. After you install the application and launch it, some installation changes may not happen until the first launch. Then exit the application. Some changes may not happen until you exit the application. Finally, reboot the system. Doing so can ensure that any files in use that need to be modified can do so during the restart. Sometimes a DLL registration won't happen until after a reboot. Finally, run that application and use it. Some changes to the system may not take place until you've triggered a feature in the product. You want to ensure that your package contains all the files and changes possibly associated with the installation. Then you can move into the cleanup phase of the process. There's a lot to watch out for here at this stage, and this is where knowledge of Windows and how it works can be critical to one's success. Merge modules are essentially Windows installer packages meant to be included in other installer setups. They provide consistent GUIDs and references so that they can be accounted for accurately. This is particularly important when removing software that contains middleware. If not counted correctly, the component may be uninstalled while another installed program is still dependent upon it. Examples include MDAC and ActiveX controls. You can capture a legacy uninstall in your package. Then you'd end up in a situation where you have two references to the application removal and add remove programs. If removing the software using the legacy setup install, remnants of the Windows installer installation still there may trigger a self-repair action, reinstalling the software to the confusion of your end users. When HKey current user keys are unnecessary in a deployment package, they can trigger unwanted Windows installer repair activity, which may overwrite changes to application settings. If you decide that HKey current user settings are necessary, or user profile config files for that matter, it's best practice to put them in their own Windows installer feature. You see, when repackaging, it's common for the entire installation to be included in a single feature, but because repairs are performed at the feature level, any trigger to repair an installation effectively reinstalls the entire product, which can take longer to perform than necessary. By placing the items that you anticipate will trigger a repair in their own feature, you can speed up this activity considerably. Temporary files and personally identifiable information are likely to cause unwanted repair activity and introduce problems upon removal of the package. Any Windows protected files also will cause an installation to fail. Your repackaging software should include a modifiable exclusion list, which will help you avoid many of these pitfalls. However, the decision to include or not include an item is often very application specific, so an understanding of Windows and how the application works will make all the difference. It's a valuable practice to get a second set of eyes on a package before exiting this phase. Have someone else in your team review the package and you theirs. Especially if you spent a long time on something, it can be very easy to overlook things that might be obvious with a fresh perspective. Whether a beginner or an expert, I recommend the Application book by Tim Mangan as a guide to how Windows and applications work. It's a very technical reference for administrators on topics usually directed at developers. If you know Windows, you'll learn something new, and if you don't have a really good understanding of how things work under the hood, this book is an excellent primer. This is not a shameless plug, this is very relevant. We're talking about research, and a breakthrough in the success of AppDeploy was my implementation of a tip library. Here people could share command line customization tips on how to deploy specific versions of a specific title. The content was migrated to IT Ninja with some navigation improvements to make tips easier to find and associate with other site content. IT Ninja contains several hundred tips on deploying a wide range of applications, but much of this database is from older versions of products, which may or may not be of help today. Today, many vendors have a better appreciation for the needs of enterprise customers and provide documentation and tools that ease the customization and deployment process. Sites like App Details and IT Ninja will often feature links to such vendor documentation where it exists, so it's still a good place to start. So if you can't repackage an MSI, how do you customize it? That's where transform files come in. A transform is a separate file that contains all your modifications so that they can remain separate from the vendor installer. There really are no changes that can't be made with a transform file. You can add or remove files, registry entries, change properties, and even add or remove pre-installation checks. As this is the same format, you can typically open an MSI and then save any changes you've made as a transform in your Windows Installer Editor. The same format, but another way of looking at a transform is a response transform. Here, you actually use Windows Installer tools to run the GUI installer manually, choosing settings, target installation paths, selecting and deselecting features, etc. Then, at the time the installation would normally begin, the response transform tool will stop and save those changes, which are typically a series of property values, to a transform file that you can use to automate those selections as part of your deployment. Now, when I say that a response transform is typically made up entirely of properties, I'm referring to public and private properties. Properties are essentially variables in an installation logic which can be assigned values from the command line in a transform or by making selections in an installation wizard. So public properties are those that can be set from the command line, and these are differentiated by the fact that they are written in all caps. Private properties can't be set from the command line, and they're not in all caps, but they can still be affected by the GUI or a transform. There are a number of standard MSI public properties which apply to all installers. And then we've got vendors who create their own properties, public or otherwise, to allow the configuration of things like automatically accepting the EULA or suppressing checks for updates in an application. This is where research comes in because it is different between all vendors, all applications, and even between versions of an application. These vendor application-specific properties don't follow any rules, so it's necessary to find documentation or tips online to discover what's available and how they work. But that said, if you look at the property table like we have here in an MSI editor, you'll normally find that many of the properties have names which do a fair job of describing their function. Now let's spend a little time talking about the test phase of the application deployment lifecycle. Conflict checking is a feature provided by most serious Windows installer management products. It helps you determine if your new package has a newer or older version of files that already exist in your environment. Will this mean things break? Maybe not. Typically, a newer version of a file will be backwards compatible with older versions. However, it can provide valuable indication of where things may go wrong, which can then help you focus your testing. You can remediate these issues by updating older packages and retesting. This issue of conflicting files has diminished over time to the extent that conflict checking is often done after a problem is discovered in order to help isolate it, as opposed to as a proactive step in the process to gain foresight. But if you have a large application portfolio and your application testing is not automated, conflict checking can help you to focus your application testing on those applications most likely affected. Of course, you'll be testing the application that you're deploying, but you'll also want to check for potentially damaging effects the installation may cause on other applications and functions. You can't test every feature of every application, but as you introduce an application, it's wise to create and document at least one or two actions that you intend to perform in order to qualify the application as functional. If you've done conflict checking, you can focus some, but your checklist of tests should be an evolving document that you add to regularly. You'll add one or two checks to be performed for each application. In some environments, maybe just critical ones, but you'll also add a check for anything that slips by so as to ensure that you never make the same mistake twice. Again, make sure that you perform your testing as a regular user and not an admin, so as to encompass any potential permissions or access issues. Deployment testing is key. Just because your package installs and tests well from the command line does not mean that it will behave the same when deployed using your systems management solution. It may behave differently due to other processes running on the system during the installation. It may behave differently due to different software being installed on the system. It may even behave differently because of the system context with which the installation is performed. Therefore, having a group of systems which are representative of those across your organization is key. These users should not be admins, but everyday users, and it can be helpful to refer to these users as your early adopters, or in some way that makes them feel privileged to get an early view of things to come. This positive association is key because by design, these users will encounter problems from time to time, and you want them to anticipate that. These users must be aware of what you're doing, what has been deployed, and what you need of them to verify success. For some applications, you may want them to run it and perform a documented action or two. For some applications, you may just want them to go about their daily routine and report anything strange. Naturally, you don't want to push an application that breaks anything. This is obvious, but talk to any packaging team that deployed a bad package and they'll tell you it can be the start of going down a difficult path. When you do your job right, things just appear like magic. New applications, updates, etc. magically appear on the end user's desktops, and all is well with the world. Then one day, a deployment breaks a commonly used tool or causes an error message to appear on the screen. Now you're exposed. Everyone wants to know what happened, and while the answer may be simple and even excusable, it shines a light on the fact that there's a team making changes out there, and that exposure is a bad thing. Soon, anything that goes wrong with the end user system is potentially the fault of this mysterious packaging team. It took a long time to log in this morning. Must be the packaging team. I can't find a shortcut or a document. Maybe it's something the packaging team did. Once package deployment becomes a well-known potential cause of problems, you may find yourself regularly on the defense to where you may need to start being very open and broadcast all your changes to help deflect being a target for anything that may go wrong. One aspect of the testing phase that can be easy to overlook is the uninstall step in the application deployment lifecycle. Especially for repackaged software, this can be a source of problems due to the inclusion of items that should have been excluded. Execute the uninstall of the software from a command line and make sure it performs as expected. Check to ensure all files and folders and registry entries associated with the application are removed. If they're not, you may want to take this opportunity to document that and/or create a script to address these artifacts. Leaving files behind after an application has been removed can result in a cluttered and ultimately slower system. It may also lead to false positives when it comes to application inventory collection. And finally, files left behind can cause problems if the application, a newer version of the application for example, is later deployed. Next, we'll talk about the deploy phase of the application deployment lifecycle. Rolling thunder is a term sometimes used to describe the gradual increase in the scope of a deployment. By not deploying to all systems on day one, if something goes wrong, you haven't affected everyone. If an issue is not identified in pilot, you will have affected a minimal volume of systems. Then, of course, when you identify the issue, you should see about adjusting your testing process or deployment testing process to be inclusive of the issue you've discovered. In larger environments, deployments must be spread out simply due to the impact it can have on the network, but even in small environments, it's wise to break things up. After a successful pilot, hit a larger group, wait an acceptable period of time before moving forward with a larger group. Then do the same as you push to a larger group and so on. As the deployment progresses, so will your confidence in the deployment and the prospect of a mass deployment. Management solution you have in place, you may get varying results and may need to look to external tools to confirm success. When you execute a successful command, an error level of 0 is returned, indicating success. Some systems will report success based on this alone. Others will require that you specify detection criteria so that application-specific files or registry entries can be used to determine the presence of the application you deployed. Others still simply look to the computer software inventory. If the application deployed is now present on the system, that is considered to be a success. Apart from a verbose logging capability, Windows Installer will report error codes in the Windows event log. It may also be returned to your deployment system, indicating problems with the installation. There are dozens of error codes. Here I highlight some of the more common errors you may encounter. A quick web search will provide you with a complete list. Some errors are more helpful than others. For example, 1603 is a catch-all which is returned when the reason for failure is unknown. At this point, your best bet is to specify verbose logging so that you can better track down at what point the installation is failing. Finally, let's discuss the patch, update, and remove phase of the application deployment lifecycle. The more applications you have, the bigger the effort, but it's important to stay on top of updates. It's helpful to have multiple people watching for announcements, as was a benefit I highlighted earlier when discussing the assignment of an application owner. There are solutions that can help to alert you of security updates, and even others that help you focus such alerts on your specific software asset list. Security updates are of particular interest these days, as we see highly publicized breaches are commonly the result of unpatched third-party software. However, non-product related updates are also important. When new capabilities are announced, users will expect to see those available to themselves quickly. Especially when paying for maintenance, getting the most out of your investment means keeping up with functional updates of the product. When an updated application becomes available or a new patch is introduced, this can trigger multiple efforts based on your deployment process. It's common practice to create a fresh deployment package that will install over the old copy, typically starting with an automated removal of the previous instance. With a vendor installation, this may be done automatically. This can introduce challenges if you customize your installation, as you'll want to ensure that your customizations are preserved by applying the same customizations to the new package. If the application is part of your baseline image, you may need to create a new baseline image to avoid pushing vulnerable software and then patching it as a matter of practice. Hopefully, your image baseline is made up of automated tasks and can be easily reproduced and updated by simply replacing the new package with the old one. Package updates as packages is pretty straightforward. Replace the old package with your new one and redeploy as you did it initially. However, an increasingly common method of deploying updates is to do so as a patch and not a package. In this case, the deployment is handled by the Windows Update Engine, commonly referred to as WSUS, or Windows Server Update Services. SCCM also provides a patching capability driven by WSUS. As a regularly running task, the service can determine systems in need of a patch, download it, and install it in the background as you typically see Windows updates being deployed. This can be of particular benefit to mobile or often disconnected users. The downside of deploying as a patch is that you may lack the controls necessary to leave older versions in place, such as the Java runtime environment, which may be required by some of your applications. You may also see challenges deploying specific editions of a product or controlling the update of a licensed software package in a way that does not render it into a free or demo version mode. Capabilities vary from solution to solution, so beware of these pitfalls as you're evaluating such solutions. Even if deployed as a patch, operations will still want to update their package, and if necessary their baseline image, to avoid a situation where a new system or new application request results in the deployment of a known vulnerability and remains exposed until such a patch is deployed. At some point, a product will reach the end of its life, either because the vendor has stopped supporting it or because you've replaced its functionality with another solution. When a product is flagged as EOL by a vendor, this should be a red flag, as this means no more updates and no more security fixes, leaving you a potentially big security hole. As stated earlier, the fewer applications you have in your environment, the better. So it's a good idea to rationalize what is really necessary and remove software you do not need to support your business. The application deployment lifecycle is represented as a circle because it's an ongoing process. We discussed the importance of knowing what software is on your network, as well as what's being used and what can be replaced or retired. Then we talked about the benefits of documenting applications and the importance of assigning an application owner. Then we talked about packaging, about legacy and Windows installer setups, the pros and cons of legacy setups versus application repackaging, and we covered some tips on how to best manage each kind of package. Then we talked about testing, the importance of testing, which things to watch out for, and the potential negative impact that poor testing can have on your reputation of your packaging team. Then we discussed the rolling thunder approach to rolling out applications, ways to determine the success of a deployment, and some common errors that you might encounter. Finally, we went over the concept of patch versus package deployments and the importance of removing applications from your systems as situations dictate. I hope that you've enjoyed this presentation and have found it valuable, and it's a very broad subject, so there was a lot to cover in this period of time.